Dom Davis needs no introduction, but as you can see, he's a very busy man. And I won't tell you anything about what he's doing because it's coming up very soon. So just a quick rundown of the events coming up for Norfolk developers in the next few weeks. On June the 25th, we've got Jamie Bradley talking about how he's built an app to manage his diabetes using Jamstack. And we'll also have Jez Higgins on the 2nd of July, taking us on a journey into space, which from the description, I believe is something to do with agile and game development, but I'm not entirely sure. So we'll be looking forward to see what that's all about. Don't forget, every Friday, 5:30, Social Club happens. Feel free to drop in any time between 5:30 and 7:30 onwards and see if we're still there. It has been known to run on quite late on some occasions, but we'd love to see you all there. More than welcome to join us. Don't forget the Discord. I'm sure most of you are already part of the Discord, but if you're not, scan this QR code in the next 5 seconds. Otherwise, I'm sure Alex will drop a link in the chat shortly. Shout outs. Now, if anyone would have any shout outs they'd like to share with the group, now would be the time. I think we do have one. Is that true, Alex, from Brew Digital?
Yeah, so Brew Digital are looking for a senior web dev. Looks like an interesting position, local agency. So if interested in the position, I can send links, or there has been chat about it in Discord. Also on the lookout for a potential freelance Android developer for a freelance gig with a local company. Needs some experience with Bluetooth potentially. And a local social enterprise as well is looking for a developer at the moment. So if you're interested, give us a shout. That is me. That's all I have.
And that's Alex with the weather. And then we'll stop mucking about then, and we'll let the gopher tell us to get on with it. Over to you, Dom. I'll stop talking now.
You need to stop sharing. Right. Let's see if I can share my screen. Share screen. That one. Excellent. So, this is an image that Alex actually picked for advertising the event. The original slide, I think, just had me down as Dom. And then Alex made a comment about people having long names and long titles. So I gave him my full name and every title I had, plus some I made up. Hence the slide that Sean was using. But this is not a satisfactory picture. This is a piece of concept art that was released, I think, prior to the game. And it's a bit of a mess as far as I'm concerned. This is more satisfactory. This is actually an in-game shot from update 2, where I had a little bit of a satisfactory problem. That's 502 hours, 39 minutes and 54 seconds when I took that image, and I hadn't finished building what I was building in those 500 odd hours. So little bit of a problem. This is update 3 that we're now playing. Big changes in update 3, so I started again. Also, I rebuilt my machine before Epic introduced cloud save. So that wonderful moment of, oh, where's my save game gone? So in this particular save game, I only have, where are we, 205 hours, 43 minutes and 20 odd seconds. So quite an early stage game. And one of the things I've found is that I want to build the perfect factory. Now, for those of you who don't know, Satisfactory is a first-person game, very similar to Factorio, where you land on a planet and you can mine resources to build things. So you can build factory buildings that will combine resources to build other things, which you can then use to build more complex factory resources, and so on and so forth. There is little point to the game other than to feed this space elevator with stuff up to a point, unlock everything, go exploring, and build the perfect factory, where perfect is very arbitrary. There are some who are trying to make the maximum amount of stuff possible using all the resources on the map, killing their frame rates and their machines at the same time. I'm trying to go for something that is aesthetically and almost algorithmically perfect as possible. So sort of playing this type of game, you end up with a spreadsheet. So you have a certain amount of inputs that come from the environment, the things that you can mine, iron ore, copper ore, bauxite, stuff like that. And then you combine these together, and eventually you build buildings and get the sort of the end stuff out. And this is all transported around, at least it was in update 2, via conveyor belts. So conveyor belts feed the buildings and spit the buildings spit stuff out onto conveyor belts, and off they go elsewhere. And as far as I was concerned, the most efficient way of solving this problem was via a bus. So central bus with all your conveyor belts going down the middle, factory units to the side, splitting things off and back on as it goes. But I had return channels, so I could put anything I wanted on a separate conveyor belt and have that split out. And I ran into problems where conveyors were colliding and it was not satisfactory. So I started doing a layout. And then I realized that my layout wasn't big enough. So my layout got bigger. This is the last handmade layout I did, where each cell in the spreadsheet represents a conveyor belt. And then the cells on the side are sort of representing the units that I'm using to construct stuff. And there's various color notation, so I know that when conveyor belts shoot off to one side and shoot off to another. This spreadsheet has bugs in it. I cannot pick up the bugs because it's using logic that is too complex for numbers. And well, it's not too complex for Excel, but just because you can do something doesn't mean you should do something. So we ditched that as an idea. And they tell us this a little while ago because I'm still using GitHub. Go make ourselves a bit of a Go program. And this Go program spat out a new spreadsheet that I may not have on this one, but was very similar to this without the colors, but had my conveyor belts in the correct order so that I could feed my factory items nicely. Great stuff. Then I got a little bit bored and went and played something else, and all of this died to death. And then update 3 came out and everything changed, and pipes were put in and fluids were put in, and they changed the way that stuff is made. So I had to restart the factory, and it all got a lot more complex in terms of the ordering of what needed to be put in, and also the ratios between production. So you may take a certain amount of one ore and a certain amount of another ore and mix it and produce an ingot, and you may take that ingot and turn it into 2 or 3 different products. You may take those products and link them together. Now with the fluids, there are some circular setups where a fluid will be input into a building and then output the same fluid. Or a good example is rubber will come in and plastic will come out, and another one will take plastic and put out rubber. So you've got quite complex things. That means I couldn't work out this part of my factory, the ordering of just how I wanted to produce stuff. So let's just grab Safari. Down you come. We have tools. So the Satisfactory calculator, online tool. We have a production planner. We can, here we are. We're going to produce. These are all the items you can produce in Satisfactory. We are going to produce a turbo motor. If I can find the turbo motor. There it is. This is now working everything out. Chunky, 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 chunk. This is the layout that I require for a turbo motor. Zoom is not what I thought it was on this. Let's see if we can do that. So that's a little bit hard to read, a little bit hard to follow. And I was finding it a bit difficult to actually get the right type of assembler and the right type of factory build-up. So the next step is do it yourself. Let's go build our own factory. Now, first of all, I'm just quickly going to Move that up there. No, that up there. Yeah. I'm on a different screen to what I'm normally on because it turns out that not everyone has a 27-inch 4K monitor. And it might have all got a bit small. Anyway, let's desktop. Come on. Do. This particular application, somewhat fun, takes your save file. Is this actually going to work with my internet and Zoom? Let's go. There you go. Reading my save file. Dun, 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 dun. So the controls on this particular tool are a bit pants, but it will give you an overview of what it is that I am trying to achieve. When my internet allows me to, I have to remember that I am in the middle of Chroma and I have 1.1 megabit per second up currently. There we go. Right.
It's frankly amazing that you can share and talk at the same time over Zoom at 1.2 megs a second.
I am maxing it out. My processor is also going absolutely nuts. Why have you not done anything? Da, 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 da. Well, that's upsetting.
While we wait for that to do something, Chris and I have a question.
Yes.
Did I hear you earlier say you'll realise that this is a later project or an earlier project because you're still using GitHub?
Yes. So my first project was working out the, I had a central conveyor. So things were split from that central conveyor into the feeds for all the building units so that I could dump my inventory into that central conveyor and it would just get sorted into the right bit, which meant that going left and right was quite difficult because you had to make sure that you weren't crossing the streams effectively. That restriction has gone. Right, this isn't working. That restriction has now gone because we've got the awesome sync. And the awesome sync allows me to just dump stuff in there. So I don't have that central conveyor anymore. So I haven't run into a problem yet on ordering of the conveyors. But this is why I was saying I could either do this for 45 minutes or I could do it for 5 hours, because if we could do it for longer, I would actually implement the conveyor sorting. Because you actually have to start looking backwards and looking forwards to work out which way stuff has to go. Right, I've switched from the web version of Fix-It Felix to a local version, which hopefully will work slightly better. If this doesn't work, we'll just move on. There we are, it's better. So this is just using the a flat version of the terrain map, and then all the assets in the game are at the right elevation. So it's going to look a bit weird. Let's go full screen. And then we're going to dun, 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 dun. If you play Satisfactory, you'll recognize this part as the Gold Coast. And this is my factory, a low poly version of it. So this is not particularly satisfactory as far as I'm concerned, because this is an old design for my fluid handling. So the conveyors go down the sides, whereas the conveyors have a main bus down the middle of the production lines. This isn't finished, by the way. So what I want to do is change this so that the fluid handling is on the outside and you just have a bus all the way down the middle. But the ordering of this is all handled via the application that we are now going to quickly write. And just to give you an idea of how insane I am, this is base number 4 on this particular game, which is eating into the remnants of base number 3, which is over here, which sits on top of the remains at the back here of base number 2, which cannibalize base number 1, which lived just in the corner down here to get me up and started. So it's all a little bit insane. Right, so let's quit out of that. And now that we've got a good idea of why we are doing this insanity, let's go have a look at some code. Here we are. So just using IntelliJ, is everyone able to see the text? I can make it bigger. Can I make it bigger? Make it bigger. Make it bigger. There we are. So all I've got is a Go module file. I had written the code, and now I've deleted the code because I can rewrite it and explain to everyone how I've done it. So first thing we're going to do is we want a factory. I'm going to put everything into a factory package, which we're going to call factory because that makes sense. And then we deal with items. So everything I've been talking about so far has effectively been an item. You've got this ore and this oil and stuff that goes into your factories and gets produced into other items and gets put forward. So we're gonna create this idea of we'll call it a product. So a nice product file. There we go. Add that in. Why not? And then with products, let's just move this out of the way. Chunk. That's the wrong one. That one. Thank you. So a product, struct. So in Go, very much like you see, you have structs for complex data types. We're going to want a name for this product, which is the string. Actually, I'm going to leap into a different type. So one of the things we're going to want, which comes from this, under game resources. So this is, come on. Items, here we are. This is a Satisfactory calculator, and it's a very, very useful tool. It splits all of the things that you have in game into these categories. So you've got ores and liquids that go into then produce your base materials, which then go into produce your base components, which and also your fuels. There's some ammos, special things. So I thought I should probably have these categories. So let's bung the categories in there. So quickly chuck in a file and call this category. Now, obviously, if we're doing this properly, we would be writing tests as we go along, but we're not doing this properly, so we're not. Now, category introduces an interesting problem insofar as we want things to be properly typed rather than stringly typed, because we do have a strongly typed language. So I could do type category string. So all I'm doing is I'm defining category as just a string. So it's effectively a special string. And then I can chuck in, and we're going to save some time here by doing this. Chuck in the categories. Now, there's nothing to stop me having just put in those string literals all over the code. But now we're no longer strongly typed, we're stringly typed, and I've then got to make sure that I do my spelling correct and what have you. This way is a little bit of duplication in the definition. I've got ores twice, liquids twice, but I can expand what those consts do if I need to, and I know that I have the correct type and the correct thing. Incidentally, there is a spelling mistake somewhere in here. I remember spotting it at about 11:30 one night and can't remember where it is. If you spot it, shout, I'll fix it. It's one of the recipes, I think. So very basic there, all the categories that we had on that other page, and the addition of this organic one, because some of the stuff that comes into a factory you pick by hand, and that's not satisfactory because you can't automate it. So I want to later on be able to filter all recipes that require organic input. So back to our product, we'll give that the category. Now I can do a special thing in Go with structs, which is this anonymous inclusion of a type. So I haven't given category a name, which means that anything that's on category is hoiked up to the top level of product. So if category had any functions, I could call it directly off product. It doesn't, so I can't. And if I need to access it, I just call it category, the name that's there. Putting this as an anonymous type in the product struct isn't really much point. I'm just being more lazy. It saves me having to type another word because I would just call it category anyway. So what else does our product have? We also have this idea of points that I'm going to put in. As I said, there's this thing that's called the awesome sync, which just takes output from your factory and turns it into points, which you can then get tickets. Then you can buy things with the tickets. It's basically a resource sink. It's a reason for having your factory going. And everything in the game has a certain amount of points that you get when you shove it into the awesome sync. And we might want to use this idea of points later. So we'll do that. But I don't agree with what the point value are for some of the things in terms of working out what order my factory should be in. So we're going to put in a modifier as well. And that's going to be a float 64 because I want to be able to get that really nice and precise. So we're going to put a function on here because my modifier is basically going to take my points value and turn it into a modified thing. So here is modified. So this function signature here, where we've got func p product, is basically saying this function lives on the product struct. So if I have a variable of type product, I can call the modified function on it, and it will return the points value multiplied by the modified value. It goes strongly typed, so we have to turn points into a float 64, which means that we will lose some precision around about 2 to the 53, I think. I don't think that's going to be a problem here. And then we can take the set of products that are defined in the game, and in true Blue Peter style, here's some I defined earlier. So my IDE is now going nuts down the side because I haven't used any of these, and Go is quite strict about what you should and shouldn't be doing, and unused variables are just a no-no, but we'll worry about that later. All of these details have been taken from Satisfactory Calculator. I sat there one night with 2 screens and wrote them all down because I am sad. So these products are combined in recipes, so we should probably have a recipe. Let's make a recipe. So one of the interesting things I've learned through doing this is I cannot spell recipe. I want to spell it like that. That is not how you spell recipe. You spell it like that. I hope one day to be able to spell recipe. Yeah. So a recipe is going to have recipe, that's a struct. It's going to have a name. We need a building type to build the recipe in. So we're probably going to need a producer. Let's make a producer. So producer. I like splitting my Go up into lots of small files, 1 file per thing. Other people have larger files. I just find it harder to navigate. This way you can have your sort of your structs and everything at the top of the file, your functions underneath it. It's all good and nice. So a producer. Type producer. Again, as a struct. That's also going to have a name. Now producers, buildings, they take power. They take a certain amount of power to run, and we need to be able to generate the power to run our factory. And to do that, we need to produce fuel. And to produce fuel, we need to take products and turn them into fuel. So we need to include power in our calculations. And also, I'm going to give the producers an order because I want to be able to order them nicely. You may notice I've got little no lint hints here. I have the linter turned up to maximum, and it's whinging about magic numbers. I am not defining constants for every single one of these. You can go away. So just turn that linter off. So these are the buildings I'm going to use in the order I would like them. I'm aware that nature itself is not really a building, but you know, let's just ignore that. So our recipe can have recipe can have a producer. And once again, I'm going to be lazy and just import that in like that. Now, a recipe has inputs and outputs, and we need some way of defining those inputs and outputs because it's more than just I take this product and I produce this product. It's I take this amount of product and produce this amount of product. So we're going to need some kind of flow. So we're going to call this flow. And a flow is really simple. Go away. So I've just had the Discord thing drop down on me. Get struct. This is a oops. Canberra can make it honest. Flow struct. This is going to have a product. So this is how much product, and it's going to have a rate of flow, which can be a floating point number. So this is a flow. So our recipe can have inputs and outputs, and it can have more than one input and more than one output. So we actually want a slice of flow. So in Go, you have arrays. Arrays are defined like that. That is an array of length 4. It will always be an array of length 4. You cannot change that length. This is a slice. A slice is a type on top of array that will dynamically resize, so it'll reallocate and produce new arrays and what have you. A slice has a length and a capacity and a few other bits in this. So it's not actually an array. It is a different thing to an array. You very, very rarely use array in Go. They're almost always slices. I do have some consts that get used a bit. This is for the various minors, just in terms of rates. And then we're going to go and grab a whole load of recipes. There we go. You can see why I'm cutting and pasting, because we're now at line 1429. There's a few of these. And I've had to turn off the linter for misspellings as well, because it's an American game. They can't spell aluminium. And a few other things. So these recipes are quite simple. This is the recipe for leaves. This is a recipe I've actually had to make up rather than one being in the game. I go to nature, and the recipe produces leaves at a rate of 1. That's an arbitrary number that I've made up. When we get out of the nature one, we've entered the minors. These are actually the game producers. So you've got a miner building. This is for Mark III miners that I've set it up, my rate's pure. And I've actually set it up for the area that I'm in. So my uranium is going to have to be normal. My sulfur is normal, whereas these extracts here are pure nodes and they come out a lot faster. So my rate is faster. So this is my input into my factory. They just have outputs. They have no inputs. As we go down, we have the simple producers. So to produce a copper ingot, it goes through a smelter. We have an input of copper ore at a rate of 30 items per minute, and we have an output of copper ingot at 30 items a minute. As we get further down, we have more complex things. So manufacturers, 3 or 4 inputs, 1 output. So here we've got modular frame, steel pipe, encased industrial beam, and a screw go in to produce a heavy modular frame. Most things have a single output, but refineries, let's find refineries, can have 2. Steel assemblers, constructors, foundries. Where are my refineries? There we go. So 1 input, 1 input, 1 input, 2 inputs here. So here we're taking polymer resin and water, and we're producing plastic. So we have all our recipes. We have our producers. We have our products and our flows and our categories. We need to be able to do something with them. We need to have a sort of plan. So let's call it a plan. Yeah. Type plan struct. So we are going to have recipes, which is a slice of recipe. And that's all we're going to put in there for the moment, because we need to think about what our plan is going to do. Our plan is going to produce each part of the factory. Did I kill? Oh, no, I didn't. It killed itself. Yep, it did kill itself. So each row in the image I showed you before, I won't bother reloading it. Yes, I really do want to exit. Requires a step. So let's define what a step in our plan looks like. Let's go and build step. So a step requires, let's type step, struct. Well, each step is just going to be running a recipe, but we may need more than one thing building that recipe. So we're going to want a count of how many things are building this recipe, and that's it. That's a step in my plan. But I need more than one step, and for reasons, I'm going to define steps, which is a slice of step. And we'll see why I'm doing this in a short while. That means I can do ordering on it effectively. I need to be able to order my steps so I've got them in the right order once I've worked out what they are. And the way that we do ordering on an arbitrary slice in Go is by implementing an interface. And to implement an interface, I have to be with a type. So let's make that a type. And we'll sort about ordering later. So we go to our plan, and our plan has steps. So let's shove it there. Steps.
Interrupt. But
yep.
Are you going to explain? That kind of explained it almost as if you weren't going to explain it. So where you're doing where you're just doing a naked like type in there,
yep.
Is that kind of almost inheritance?
It's not inheritance. It's basically you don't have to reference it. So if I was to do,
would it make up its own name for it then?
No, it's actually, it would be on plan. So if I was there, if steps had a, let's just add a function on the steps. So we have a function foo on steps. If I've got it naked there, I can, horrible function naming at the moment, I apologize. I can do that as a plan. I can just do p.foo and not have to reference steps at all. I can reference it if I want to.
So it's kind of like an extension. So if, right. So if you call it steps, you get it as steps.
Yes, and that actually allows me to easily, it's less inheritance and more composition. I can compose various types together, and that will now implement various interfaces of those types, or require, if it's in an interfaces of those types. I can then call it steps if I want to. That means it's no longer, it's no longer hoiked up. I've now got to explicitly grab it, and then I can also make it private, so that it can't be seen at all outside of the package.
I just happen to know that lowercase is private, right?
Yes, lowercase is private in Go. Pretty much everything's going to be public in this because it's not a well thought out. It's not a well.
It's a command line app. It's a command line.
So right. We want to be able to produce things. We want to be able to make our plan. So we're going to want a function. Let's call this function produce, and we're going to want to produce products. Product. That's going to return a plan. Great. Now we've got to work out how we're going to do that. That's not going to cut it. Works, but it's not going to cut it. So we are going to have to look for all the products that we want. So we're going to range through, range products. And we need to do something with those. Note this underscore here. So the underscore is the unused variable. This variable is currently red because it is unused and the compiler will not allow you to have that unused. This variable here, when you're doing a range over a slice, is the index. This is the cause of no end of why isn't this working problems in Go. Often compile time problems because you're looking at it going, I'm ranging over my products. It's like, yes, you are, but you're getting the index there. I don't care about the index in this range, so I'm just going to throw it away. And the underscore allows me to just throw it away. So I require a product. How do I go about producing that? Well, let's produce a function require, and we're going to say that we require a certain amount, a certain flow. Now, little asterisk on the front here, pointer. These are pointer functions. That means that I'm getting a pointer to P, which is my struct plan. And because it's a pointer, I can modify it. If I do that, I get handed a copy of P, and any modifications I do get thrown away when the function exits. Because I want to modify things later on, I'm making this a pointer function. Right, how do we know if we're producing enough of the stuff that we require for this product? We don't. We need some way of storing that, so we're going to have a capacity. And that's going to be a map of products. 64. No, product. Help if I was looking at the right bit.
I think you found the right way to do a key value pair in your object there. I think you just slipped into some.
No, I was looking at the wrong bit. I was looking at the initializer, not the. I have another screen with all the code. I'm not making this up as I go along. Surprisingly. Yeah, with a map, we determine this is a map, dictionary, whatever you want to call it, keys product, the value is flight 64. And we can say, right, in require. So we require a certain flow. So let's take our capacity, p.capacity, the product from our flow, and let's subtract flow rate. Now we could probably end up having negative flows here, which is bad. So if p.capacity flow product is less than 0, and you'll notice Go does not have the brackets around your ifs, or the false for that matter. Absolute pain in the backside when you're bouncing between languages that do. So if we have a capacity that is negative, we need to produce the thing. So we need some way of, we need a production function on this as well. So let's plan and produce a product. Product. There we go. Now, this produce is different to this produce. This produce is in the global scope. I can just call it. I can go factory.produce from the package factory, or if I'm in the package factory, I can just call produce. This produce is on my plan struct. So there are two different functions. Okay. So how do we produce something? We need to know what recipe to use to produce our product. And this leads us into a problem because there are lots of different recipes for different products. And what's the best way of working out what recipe that we should have? I don't know. So what we probably need to do is define some way of saying this is the recipe I want, or to select the recipe. So we're going to call that a selector. Sadly, you cannot make any kind of ranged wooden string weapon in this game. Otherwise, we would be able to have a bow selector. Sadly, we can't. So, thank you for the unmute and the pity laugh.
I had to clear my mouth full. I was eating.
There's a selector. A selector is used to determine the best recipe for an item. So it's function. We've actually defined a type as a function. So functions are first-class citizens in Go. We can pass functions around, which is great. So I can say that I have a function that takes a product and a set of recipes and returns a recipe, and that's all I care about. So we can go back to our producer, to our plan. In our producer, and I can say the recipe that we want, no I, is, oh hang on, we need a selector for our, long way around. That's how I've done it. Nope, I've made it anonymous. Done that. Probably again for reasons of laziness, but I'll leave it like that just in case. So the recipe production, we're going to take our selector. We're going to pass in the product that we want to produce. We're going to take the set of recipes that our plan knows about, and we're going to utilize that recipe to handle what's going on. Now, let's just work out what's going on here. Ah, yes. We want to go through our steps and see whether we're already producing that recipe. Because if we are, we just need to increment the amount of times that we're producing that recipe. So we're going to go through our range of steps. And this time I do need my index variable. So, so if recipe name, and I'm having to do this on names, not on the recipe types themselves, because recipe doesn't implement double equals. Go doesn't know how to do equality on that. I'm using font ligatures here for people who are confused why I've got long equals. That's a double equals. I need to say whether I found. That's my. See, cannot spell recipe at all. Now, up until now, I've been defining my variables like this, which is the shorthand way of defining things. Define a recipe, work out what the type is from whatever it is that I'm giving you. In this case, I'm saying define a variable found, it's a Boolean, and I want the 0 value because it's unset. The 0 value for bool is false. So if we found it in our set of recipes, we'll set found to true. And pivot steps is now the reason why I'm doing this here on p steps I and not on s is because s is a copy of what's in that slice. So if I just do s++, it'll update the copy and then throw that update away. This way I'm delving back into my original slice and updating the actual value there. And technically, I didn't have to pull s back here. I could have just done p.steps i.recipe name, but then it starts getting a bit long. So we'll leave that like that. Right, so now we need to update the capacities that we've got. So we're going to range through our output. Range recipe, that one dot output. So for every output that our recipe produces, we are going to update the output rate. Great thing about Go Maps is if that doesn't exist, it'll just create the entry with the 0 value and then add that on. So we don't have to work out if it's there and sort that. So
that's epic.
oh, hang on. One thing I need to do. If we haven't found, once we've been through that loop, if we haven't found the recipe in our set of steps, we need to add it to our set of steps. Because we've got another step in our factory now where we're producing something new. So with slices, we use the built-in append function. So we take our p.steps slice and we append to p.steps this new step that I'm defining. So what that does is that will, if it needs to create a new backing array, if we've blown the backing array we're on, and sort out all of that rubbish to make sure that our slice just looks seamless. So we've added the step if we need the step. We've added the capacity of the product to our overall capacity, but our recipe may require inputs that we don't have. So let's range through our inputs. And say that we require that input. Can't spell input. So now what we find is that for our original production algorithm, we can just say that we require a flow of product, which is, oh, no, sorry, wrong one. That's in my require function. Oh no, wrong one, that one, that. I've missed a step. That's that. Right, so require hasn't been finished yet. So produce works. Record and require hasn't been finished yet, so we need to finish require. So if we require something, we produce. So we produce that product. And then up here, we can say that we require, oh, we haven't created a P yet. Let's make a P. Let's make a P so that we can, it's plan. We're going to want some recipes. So let's just pass them in because I'm not going to pass, actually, yeah. Let's not pass them in for now. Let's do something very cheaty. Let's do this. Recipes is equal to, now if you remember, I defined a whole bunch of recipes elsewhere. So I'm just going to set my recipes to be that bunch of recipes. And now our p.plan has recipes of that. And we have to define the capacity map. Maps start off, their empty value is nil. And if we try and access a nil map, it'll go bang. So we'll just create an empty map for us to be getting on with. I can have it return P. And we can now, for each product, we can require a flow and just say a rate of 1 because we just, 1 a minute sounds fine. That's the one thing we have large amounts of in Satisfactory is time, especially if it's me playing. So we've now got something where I can pass in a list of products And it will go through to the products and say, I require this product. And in require, it's going to say, right, let's take this out of our capacity. And then if the capacity is lacking, and we don't have the right capacity, it's going to produce that product. And to produce the product, it's going to find the correct recipe to produce that product based on something undetermined yet, range through each of the steps, find out whether we've got the recipe, update it if we have, add it if we haven't, add the output of that recipe to our capacities, and then require all the inputs for that recipe. And that should drill down until it gets to the recipes that require no inputs. So this is our minors and our nature. Stop going through this recursive loop, come all the way back out, and out spits a plan. That is the plan. So selectors, how do we decide what is the best thing to produce? So I am going to suggest that the best thing to produce in good Top Gear fashion is the fastest. I've done a quick cut and paste here because I'm aware of time. So fastest is just going through and finding out what produces things the fastest. And one of the things we're not able to do at the moment is work out what recipes we can produce for an individual product. We can get a single recipe. So I've created a helper function, recipes for. What I might actually do just quickly, because we have now got to the crux of the crux. I'm just going to do my true Blue Peter. Ta-da! Thank you. So this is the original code. Let me just find my, oops. Snap. Nope. Let's find recipes for, there we are. So recipes for just goes off and finds all the recipes in the set of recipes we've got. And the other thing that I've done, which I didn't show in the first plan, but I've got this idea of a filter. So I can pass in all the recipes that we have and constrain things. So we actually filter all our recipes out by this set of constraints, because I don't want to be running anything that has organic stuff in it. I don't want to be filtering. I don't want to be gathering. So I have this ability to filter out organic things, which does it on a category. So the only other thing I want to quickly show before we run this is now, it can work out what type of products we need to produce. There's the hard way of doing it, where we go through and say, I want to produce this, I want to produce this, I want to produce this, which we can actually do now. Let's just see if I can move this out of the way. Oh, it goes up there, excellent. Let's run this. So this has gone off and worked out that I need, at the top end, oil extractors, water, miners. Then I've got some foundries and smelters that are making things, some refineries that are making some intermediate stuff. Then it goes off into the constructors, which are the very simple one in, one out type things. Then into the assemblers that take two things generally produced from a constructor and spit something out. Then when I get past the assemblers, we get into the manufacturers, which take 3 or 4 things in and spit something out. And some other stuff that I've done, because I haven't finished this tool yet. So this is how much power it's going to take. This is how many conveyors I need. And this is a unordered list of the conveyors. The next step is to make this an ordered list so that they all fit nicely. But one of the things I've been able to do is, let's just do it. Yeah.
Is this open source?
It's all on GitHub.
Amazing.
I could do a produce all. So produce all produces one of, or at least one of every item in the game, sort of. it effectively goes through all the recipes and works out. So we've already got a way of working out all the way to the beginning through this algorithm of keep producing stuff until we get to something with no producer. The produce all goes off and finds what I call all the terminal states. So we iterate through all the recipes looking at the outputs until we have no outputs. So, until something produces an output that has no input into another building. So anything that is produced but then not consumed is considered to be a terminal product. We can say, right, produce all of the terminal products in the game, and it will work those out based on the data. Just quickly on the step, the reason why I did steps is because I needed to do this len, swap, and less functions, which allows me to sort my steps. Because one of the things I do with that plan is that once it's produced all the steps, I then sort them into a vaguely nice order. And my order is based on, is it the same manufacturer type? If not, move it up the order list. And then does anything require it? Is this required by anything? Sort of. So this just uses an internal Go, which I think is quick sorting algorithm. Does a quick check. I want to change this sorting algorithm, start doing look aheads and look behinds to work out whether or not there are references that I've missed that I've not been shown. So let's go look through the entire set of recipes and work out, am I bigger than or smaller than? But then I've got to solve the problem of the circular recipes. So hopefully, in a few months' time, when I have solved all of the extra issues, so the sorting of the conveyors, the sorting of the ordering and the handling of the circular structures, I will then have the blueprints for what I consider to be an algorithmically perfect factory. And I can stop playing Satisfactory and go play Elite. Which I have a tool for, which I've also written in. So, I mean, that's that. This is what I do for fun. It's on Bitbucket. It's open source. You may use it, abuse it, laugh at it, ask me questions about it. It's there. I don't make any claims to it being any good. It works for me. Do we have any questions other than why?
I think we all have to set aside the why question, John. We just have to accept. I mean, it's possibly the first Go demonstration I've seen that doesn't have any channels in it, which is nice. I wondered if you'd thought about Prolog, because this feels like an inferencing problem. And when you started there saying forward, look aheads and look behinds, I wondered if actually Go is not the answer here. I know Go is mainly the answer, but to many things. But I wonder if it's not like this is a rules engine, right?
So a long time ago, many years ago, Jez will remember these things. We had these teaching, the universitarians. I had a Prolog course.
Of course.
And we had our mock exam, and the lecturer came in with the sheet of results and said that if this had been a basic test in 4 different variants of BASIC, or a test in C, C++, Perl, and there was another language as well, which escapes me at the moment, then one of you would have scored quite highly. Sadly, this was a Prolog exam, and you got nothing. I missed all of my Prolog lessons, and it turns out that Prolog is a very, very different language to anything that I had done previously, very different. I have subsequently been exposed to Prolog once more in a previous role where I was instrumental in ripping it out and replacing it with Node.js. So you may clap, Alex, you helped. So yes, you are correct. It is an inference engine, but I would not turn to Prolog. I would turn to graphs. and actually put this into a graph. Yeah, so one of the things that we might do as a bit of a, I don't know, joke, with my grown-up hat on, I am CTO of a company that does a lot of stuff with graphs, where you can sort of go through and ask effectively questions like this, and it can go off and find the various routes through the system. So I may apply it to that. The issue there is the circular part, because these are not DAGs. These are definitely cyclic in some cases. So I may have to work about it. But you are correct. Go may or may not be the correct tool. However, I am a Go developer, and I tend to write most of my gaming tools in the language that I am currently using, or the language I am forced to use. So for World of Warcraft, I had to use Lua, so I use that. For Elite Dangerous, I have to use C#. So I know it pains me greatly, but I looked at doing it in Go, and it can be done, but just because it can be done doesn't mean it should be done. It's a real cut your nose off to spite your face type scenario. It might be an interesting problem to learn Prolog, but I have zero interest in learning Prolog.
Oh, come on.
No, there are other languages I want to learn before Prolog. Many other languages I want
a
to
slightly
learn.
more horrific example. Chris Dunbirch is saying that he wrote a StarCraft 2 replay analysis tool in PHP. So 0 out of 10 would never do again, he says.
I mean, what you have to understand is I also have other languages that I could use to write this in. So, I mean, I could go off and write this in colonoscopy or Old Lang first. It would be a horrific problem to do in either language. Colonoscopy?
Colonoscopy as a language?
Yes. Yes.
I understand that as an operation.
It's close.
Don't Google it. Don't Google it. I'll put this on YouTube.
So colonoscopy is identical to brainfuck with different operators. It was written when I first started writing Go because there were no semicolons, and I felt, because people were also banging on quite a lot about Python at the time, which has, of course, no curly braces, and I felt that these two characters were being ostracized from languages, so I found a home for them. The only difference between colonoscopy and brainfuck is that every command in colonoscopy is semicolon terminated, even if it includes semicolons. And then come on, really? Have I not submitted this yet? Here we are. This is entirely Chris Aldwood's fault, but this is another language which will.
I saw the tweets going around.
Yeah, this one will actually run Old Lang Syne and do something with it. And I've managed, with the way that you initialize the memory, I've managed to get around the problem that Old Lang Syne doesn't actually do anything useful, because you can make the argument that the happy line isn't part of Old Lang Syne, the poem, or hasn't been handed to us, so we don't know how we're initialized in the memory. So there may well be a memory space where Old Lang Syne does something useful. But again, these are joke languages written in Go, which I do in order to learn something new about the language. So a lot of the stuff I've been doing with the Satisfactory stuff is getting into the idea of one of the idiomatic ways of writing Go is to produce, to accept interfaces, but produce structs, which is not something I've been doing a lot of. I've been doing a lot of stuff which is pure interfaces, because I used to be a Java programmer. So this has been me experimenting with playing with structs more than interfaces, and only using interfaces when they're actually required. And although it's a jokey thing, it allows me to go off and do something useful that I will use, a bit of a laugh, and teaches me something or a new aspect of the language, allows me to go off and do that. So the web development stuff I did with my Planck services, where I have this idea of you can orchestrate a computer because each of the Planck services is a NAND gate effectively. So if you spin up several billion of these, you can implement your own hardware. So it's beyond serverless, it's hardwareless. It becomes expensive, but but again, it's just one of these very stupid things, which is very small and self-contained, and you can work out what's going on, but you can explore another aspect of the language. Anyone else?
I think we're all a bit stunned from the colonoscopy and all that languages that have just been presented to us, to be honest, and feeling fairly fortunate that your Google search didn't return anything that I can't put on YouTube.
So I work in IT. I know how to keep my browser history clean.
Thank you. That was interesting. Now I want to rewrite something that I've written today in Go, which I guess is the point of these talks.
Well, this is it. So, I've already gone off and started writing 3 games from the TIC80 talk. All good fun, and in fact, that's been really useful for doing this type of presentation programming, because the TIC80 editor only gives you 40 columns. And I don't know, was it 10, 15 or 20 lines or whatever it is. So you have to have your code nicely produced in this small block rather than these Leviathan huge blocks. So it gets you into this nice habit of writing small code. And then you can have unicorns floating around. And my hope is that when Jez does his talk, it will inspire me to go off and write Space Invaders, not Space Invaders, asteroids in TIC80. And then we want to get really nerdy and do it properly with a laser, so you get the proper drawing for asteroids, which has been done.
Have you got a cathode ray tube somewhere to manipulate?
You got to do it on an oscilloscope.
Yeah.
I do not have a cathode ray tube to manipulate yet. That's a lie. I have a hub monitor at my parents' house that straps onto my BBC B+.
Make sure you stand on the mat when you take it apart. This is my first look at Go. I've not done anything with Go, but you were using IntelliJ IDEA. Isn't there like a Go?
Yeah, so there are 2 reasons why I use IDEA rather than GoLang. The first one is that I hate my machine and I want it to work hard. So I don't want to have individual projects and individual versions of IntelliJ or GoLang or whatever open for all the different things that I'm doing. And only IntelliJ allows you to organize all of your projects in one project, if that makes sense.
I get sense, yeah.
So I've got all my code in here. Secondly, I'm not just doing Go programming in here. There is some PHP, there is some JavaScript, there's some other various languages. So effectively, this is GoLang with the IntelliJ full fat wrapper around it rather than the nice thin one for GoLang. So it does everything that GoLang does. It can sometimes be a couple of weeks behind in releases. But one of the interesting things I found is that this is a Java IDE written in Java, and I've customized it so heavily that the last time I went to run any Java in it, it wouldn't compile it.
Yeah, that's
the default state of Java, isn't it?
Yeah. So,
uncompilable.
but I have done some Java in here as well. There's Bash stuff in there as well. There's it takes all the plugins.
So if you had PyCharm, you just use, if you were to use Python, the PyCharm kind of aspects, In
Yeah,
idea.
just you install the Python plugin,
Oh, nice.
which I have installed. So I can edit Python in here. I can edit. It's aware of quite a few things, and I've also made it aware of. Do I have? So it's also aware of language that this is a DSL that we have. So it's very easy to make it aware of other languages. It's not context aware like it is with things like Go, but it is syntax highlighting aware. So it becomes nice and easy. And yeah, you can do the same with Sublime and stuff. And I do have, but I do have Sublime. I use that for things as well. But IntelliJ tends to be my go-to for pretty much everything.
VS Code
including,
do Go syntax as well. I'm guessing.
Yeah. It does Go. It does Go syntax. It also does. Real front-end developers may want to look away.
It does do all of this at the speed of honey dripping down a wall, though. So,
okay, it's like Ginger.
If you'd like some speed,
Template tags.
grab Sublime Text.
So this is Go.
License.
I've got a license for Sublime. I've got Sublime Text. So this does a lot more than Sublime does. I would be lost without. I was watching Paul do some Go remotely, and he was aware. And just like that. But he was doing it in. I think he was using VS Code, and it was just painful watching him struggle through without all the extra hints that the IDE gives. Yes, it's not as fast as Sublime. Yes, it's not as fast as Vi or Vim. Yes, I have been known to go down here to my terminal and edit a file using files, which is just fantastic. But it does a whole load of extra stuff that I like. And one of the things I really love is this ability to go back in time and look at files as they were in the history. So that's what I've been using for this demo. Is I have this window, which is I bunged in a checkpoint, and then I can just go through and have a look at how my file differs from the other file. And this is external to Git and source code control. This is just something that it provides, and this has saved my backside on more than one occasion.
The refactoring is quite good as well, isn't it?
Yes, the refactoring is very good.
Yeah. If it's anything like PyCharm.
Yeah, it's
In fact,
it's not cheap.
Spaces and stuff is pretty decent.
Mm.
Yeah, it's 190 something quid a year, which is not cheap. There are community versions available, but it is worth it to me. It's one of the few products where I don't mind dumping nearly 200 quid on every year.
Yeah.
Tonight's podcast has been sponsored by.
All right.
In fact, you probably could get to do that. They are very liberal in their have a license as a raffle prize. I'm sure. Actually, you could be giving away IntelliJ licenses every month if you ask them. That's where half my JetBrains licenses came from. I'd happily pay for the other half, but you know. So.
May speak to Mr. Nash about that.
Yeah.
And the other thing is they are quite responsive to feedback. So they're at a number of conferences that I go to, and you can sit and chat to them and say, this thing annoys the hell out of me, or there's this bug, or can you change this? And they do listen.
Okay. This Go HTML, because I've not looked at Go at all. Is this very similar to like Ginger templating in Django?
Having not seen that, I don't know. But handlebars is the closest thing I could tell you. So
so you can put template strings in.
Yeah, so I can turn around and say, here is a type, show it in the data, and off you go. So it's simple, it's nice, it's easy. If you want to do anything complex, then I would suggest moving to a proper JavaScript front-end type framework. But for what I'm doing, this is perfect.
I like how IntelliJ is hiding your shame with those style tags that have just got dots inside them. There's nothing to see here.
That's actually the way the Bootstrap recommends.
Yeah, Python.
So if you're just overriding something one-off, apparently shove it in line. Because they were all in a different CSS file. But then I realized they were all one-off, and I was having to come up with ever more esoteric names for things to try and make them more.
The age-old problem of naming things. Huh?
Yes. And in the end, it's just like, well, why not stick it here? Because now I know what it is and what it does and what it relates to, and what have you. Also, not a front-end developer.
No. I was genuinely envious of the way that it was hiding it in that style.
So it'll do other things like that in terms of you can shrink your stuff down, but it'll also give you, and I've turned this off, but it will give you hints for various. So when you're putting parameters into functions, it'll tell you what the parameter name is. But I'm old school. I want everything to be 80 columns, and I'm slowly trying to wean myself off that. And if you put the little thing in the 80 column, if you put the little slug in there, you don't know whether you're on column 80 or not easily. But this is why I've got this line here is 80 columns. This one here is 85 because Go says don't split the line just for the sake of splitting the line. So I now have this thing that, okay, if it just sneaks over up to here, I'll accept. And then this, I think, is 120. And if you go past that, that's too long. But then the linter will also complain.
Talking of 80 column lines, Jez, do you have an email editor that has column lines in it, or is that something you're doing yourself?
They're just plain text emails, Alex.
Oh, okay.
God intended. But
Yes,
they are, of course, got line breaks. Column 72, I think it is.
72. Okay. I remember trying to somehow emulate that initially with your emails, and then was just like, yeah, no, I can't do this in Gmail.
If they go beyond column 72, he has problems reading it in his hex editor that he's using.
I missed that, sorry.
I just need the words. I don't need the colours and the pictures and the things.
No.
Important.
Agreed.
Ugh.
It's just easier to slap Gmail into my address bar. Well, thanks, Tom.
Well, yeah, indeed.
This is a well. You're not good.
I guess the conversation and the questions are seemingly drying up. So should we take this opportunity to wrap it up and
I can roll 2 meters that way and boot up my machine and start playing
do
Satisfactory.
show us it in action.
It's that.
I'm sure if people want to stick around for that, we're open to running it.
That's on that machine.
Slap a Twitch link in Discord.
Does the game have an API? Can you not just pump the output of your program directly into the game and get it to build itself?
No, but that tool that I was showing you allows you to manipulate your save file, and that has a JSON format that you use. So I could eventually produce the factory without producing the factory, but part of the fun of the game is actually building the. Is building the.
It's part of that.
So like you've got to do the intermediate thing. You've got to build the stuff to build your factory, to build the next thing, right?
Well, no, I mean you could just stick it into the save game, but at that point you're effectively cheating.
You start with I don't know, like sand and cement or something, and then you make a brick and you build a thing. And
So you start mining by hand. So you go up and you just chink away at the things. I have pretty much all the resources I need to build whatever it is that I'm building. I am now just doing the building. The reason why I haven't finished doing the building is because each time I start doing the building, I find that there is some little niggle in my build that needs to be fixed. Hence the trying to write the algorithmically perfect factory So this code will get tweaked. I will then go spend another 100 or so hours rebuilding the factory until I find the next nickel. And then the code will get tweaked and another plan will drop out. And eventually, hopefully, I mean, you are correct. What I should do is use Jason to produce the model, then walk through the model and work out whether it is correct, and then just build the end bit. But that then removes the whole point of playing the game.
It seemed to me like that's where you were trying to go. All right, solve that one. Next, please.
Limits to the madness. I probably will never actually finish the factory because I will get to the point where, okay, this is now going to be perfect. All I need to do is invest time. Next game, which is generally what happens. But yeah, we'll see. So next week we've got a 45-minute walk around my Fallout 4. Actually, I think that's on YouTube, but it is a 25-minute walk around.
I've been talking of APIs that hook into games. I've been trying to get somebody along to talk about Minecraft because apparently you can basically hook Python into into the Minecraft server and start pumping data in and out of it.
I think James at CPI is working on a tool.
So I messaged. You mean James Taylor?
Yeah.
Yeah, so I messaged him on Twitter and was just like, "Come on, you've got to talk to us about this Python tool that you're using to automate Minecraft. Like everyone's obsessed with Minecraft right now. It'd be brilliant." And he replied to say, "I'm not doing that. That's not what I'm doing." I was just like, "I'm pretty sure that's what you tweeted about, but whatever."
He messaged me about it, the Pygame tool he made, and he says, "I blame you for this." The TKT stuff and the Pygame stuff. So. He's like made an isometric version of it, but I think it's still in development. But yeah, it's interesting if it is a Python API.
Yeah.
Minecraft.
So certainly with Elite Dangerous, I'm using APIs that other DLLs expose, which then take game information. So they've done the heavy lifting of pulling the Elite Dangerous data out, and then I'm using that to effectively just generate events. And then feed that through voice attack to give a text-to-speech voice feedback. So yeah, I've been using the API. So that's all done in C# using the DLLs that these things provide.
I'm guessing it's not as fixed as it was on the ZX Spectrum. You don't have fixed.
No, it's come on a little way since then.
Oh God, I know. I was just thinking, old EME version, like you can't just have fixed exchange rates. You can write a little Go script that can work out.
Oh, yes, they're all, and in fact, there are huge APIs out there that people access, and their game does OCR, pulls the values. Or this was before the APIs were opened up. They have people running OCR on their screens to grab the values off the game to then feed the database, so you have real-time updates of all the prices. So this is the level. You think I'm nuts? This is low-level nuts. This is just command line interface. This is just a little bit of maths. Other people are doing insane things, really insane things.
Or something like that.
So, so this is my voice attack plugin for Elite Dangerous, which hasn't been touched for a while, but all goes through and hooks into this thing called EDDI. So I had to teach myself C# to write this. And we've got a lot of help from the community. It's great because you just turn around and go, right, I'm learning how to do C#. I'm a Java developer. What's different? And I got told to install StyleCop, which was a huge help.
Yeah, it looks nicer.
Where else can you have functions?
Nicer than what, Kev?
Well, nicer than the stuff I was looking at. I was looking at Unity.
Oh, I thought you meant nicer than Go.
Oh no! Go is nice. Yeah, Go is nice. Go kind of reminds me of Python in a way.
So Go is quite Python, especially with the way the interfaces work. It's very Python in that respect.
Yeah.
C# is like Java.
Gone from being a Python dev to a Go dev quite easily.
Yeah.
I'm guessing that's quite common.
But this won't look anything like Unity stuff because I'm not doing any graphics. All I'm doing here is taking events from one DLL and throwing it through a speech engine.
I had that Unity used to run on Python. I'm gutted it doesn't anymore because the C# stuff in Unity just look crazy.
Cool. Well, I'll let people go off and wander about life.
Without traveling too far and things like that. All right, then. Well, thanks very much, Dom. That was very entertaining. I look forward to next week's extended walkthrough.
Well, like I said, that's on YouTube already. You can go watch that.
Oh, okay. Well,
I'll drop a link on the Discord.
Discord. Yeah, absolutely. We'll look out for that, and we'll post it in the show notes as well.
Excellent. Thank you all for coming. It's been fun.
Should we leave it there then? Nice one, guys. We'll see you all next time.
Cheers, Dom.
Cool.
Cheers, Alex. Cheers, Sean. Thank you.
Thanks, John.
Bye-bye.
Bye.
Thanks, everyone. Cheers. Bye.